Some people think of XState as only a front-end library, but it can actually be used anywhere JavaScript runs, and its most exciting cases are actually on the backend. Here I'm creating a createUser function, which takes in a name, and you can see there's a test failing about it. We're expecting createUser to create the user in the database. And if I go to my test file up here, it's saying it should create the user, and it's expecting this database here to match the object name Matt after I create the user. So the simplest way that I can get that working is I could just take this name, give it an ID, and append it to the users thing here. So let's see what that looks like. So here I'm saying db.users.push ID 123 and the name, and you can see that our tests are passing. That's because the tests are asserting that there's a user in the database with a name of Matt. Let's now put this in XState and see what comes of it. We now have a very simple state chart that describes what our process is doing. We start in the adding user to database state, where we invoke the add user to database function, which just does exactly the same thing as our function did before. When that's done, it goes to the complete state, which is a final state. So you can think of this, because we're inside a promise here, this is an async function, our promise has to return at some point. And for that, we use the wait_for function, which we get from XState lib wait_for up here. And what that's doing is it's just waiting for the state to be done. And over here, this is going to be the final state that it's in. To run the machine in the first place, we use interpret here, which just runs the machine and it just returns the actor. So here, this could just go on forever and ever, but we're using wait_for to wait for it to be in a final state, which kind of converts the actor into a promise. Inside the services, we're grabbing the name from context, which is the same thing that we passed in just here. And as you can see, our tests are still passing, meaning that we have exactly the same behavior as we had before. Okay, let's add some more requirements now. It should now fail when the user's name is David. So here I'm saying await user or wait create user, and I'm waiting to catch it. And when we do catch it, I'm saving the error message as e.message. And I'm expecting error message to match David cannot be created. So in our state machine now, we probably need a state for saying you can't pass in David. And we're also going to need an error event that comes out of this adding user to database here. We can add the actual implementation here inside our add user to DB service. There it looks a bit like this, where if we say context.name is David, we're throwing an error, you cannot pass in David. But there's an issue here. Our test is timing out. I wonder why. We're probably throwing the you cannot pass in David properly, but we haven't marked you can't pass in David as a final state. What that means is that by default, wait_for will wait 10 seconds for your app to resolve into a kind of normal final state. And you can customize this here. So if I want to wait just 2 seconds, for instance, then what you'll see is it's going to fail with a different error. So it says timeout of 2000 milliseconds exceeded. So I'll remove that and I'll mark this one as a final state. With type final, we're now not getting the same error, we're still getting a different error, and that's because we're throwing the error inside here and not out in here. I've added a console log here to just check the final state.value, and we're ending up in the you can't pass in David state, but we're not actually doing anything then. What we should be doing is checking if we're in the you can't pass in David state and then throwing the correct error. So the way that looks is we say if final state.matches you can't pass in David, throw new error, David cannot be created, and you can see that now our tests are passing. To sum up then, we have a happy path where add user to DB doesn't error and we end up incomplete, or we have a sad path where add user to DB does error and we end up in you can't pass in David. And both of these are simulatable with the visual editor. Let's sum up all the pieces that we need to know to start using XState on the back end. We have this wrapper function, which is our async function. We interpret our actor, which is based on the machine. The machine kind of lets the actor know what it's supposed to do. And then we pass the machine the context it needs, which is usually the inputs from the function here. The final state we get from waiting for the actor to be complete. If the actor takes more than 10 seconds, then by default, it just times out, but you can extend that timer if you want to. Every finishing state here must be marked as final, so that we know that we can just go state.done as the condition for waiting for the actor to stop. Then when we have our final state, we can check which state we're in and do different things or return different information based on what state we're in. And that's it. I think XState in the backend is a really, really nice combination. I've put it into production before, and it's made for really, really readable code that anyone can jump in and visually edit. I hope you like this video. There's going to be more on this in Node and React and testing and all sorts of cool stuff, so make sure you subscribe, and thanks for watching.